All right. Hello, future math teachers. Today I wanted to go over the last section of Domain 2, which is patterns, algebra, and functions. So we're going to look at understand rational, radical, absolute value, and piecewise defined functions. And we'll go through a few examples just to give you an idea of what you're going to see. But again, we can't get through everything. This is just a little refresher to get you going so you know some of the concepts to study. So let's get to where we need to be today to start with. Okay, so here's a little more description of this portion of domain 2. You can see that we're going to be working with rational, radical, and absolute values piecewise, all different processes with them. Real world, analyzing them, those types of things. Okay, so let's go ahead and get started. Let me get my pen activated here. And where it goes, there it is. Okay. So let's look at our first one here. We're asked to find the domain. So remember when you're dealing with a rational expression, you want to make sure that one thing is the denominator can't be equal to 0. That's going to cause issues. And you have to check to see what the other parts are. So in this case, we have a square root as well. With square roots, we want to make sure that they're positive so they don't go into the imaginary. So let's start off with looking at our numerator of the square root of x plus 3. So for this one, we want this to stay positive. We only want the values when this is positive. So we set it greater than or equal to 0. Greater than or equal to 0 is going to give us positive results. Okay. The denominator of 2x plus 5, we want to know when this is going to equal 0. Because we don't want it to equal 0. That's going to be our issue spot. So let's go ahead and solve each of these. So the first one, we would take the square of both sides, but we're working with 0. So that's just going to leave us x plus 3 is greater than or equal to 0. And subtract 3. So we get x is greater or equal to negative 3. And on our other side, we subtract the 5 over and divide by 2. And what ends up happening is this is what we don't want x to equal to. This would cause our denominator to be 0. So we have interval notation here. So maybe putting it on a number line would help just to get an idea. So let's start with our first one here. We have x is greater or equal to negative 3. So we have negative 3 greater than or equals to is going to be to the right. And greater than or equal to tells me that it's a closed circle. We want to include negative 3. Negative 3 is allowed to be used. If we plugged it in, it would just give us the square root of 0, which is 0, which is fine. And then greater than is going to be pushing to the right. Now, we end up with an issue here at negative 5 over 2 or negative 2.5. So if we envision negative 5 over 2 here, what ends up happening is as we're going greater, we have a spot, open circle, where we're not allowed to use that value because that's going to cause issues in our denominator. So now that we have it on a number line, we need to convert over to brackets and parentheses. So closed circles means you're including it, the same way that a bracket means we're including it. So bracket negative 3, comma, we're moving along. We get to negative 5 over 2. We have an issue. So we don't want to include that value. And again, we don't want to include that value. This tells us that we're just not including negative 5 over 2. And then it's going to go on forever. There's no other issues. We're working our way through. So let's match up with what we've got here. So negative. Okay, so it looks like C is what we're looking for. So some of those concepts of working your way through, again, with these, you could do some guessing and checking to see, but you need to remember what those brackets, parentheses, closed circles, open circles mean. Okay. So let's go on to our piecewise function. And probably the best way to do this is to set up maybe a table for each, if just to be safe. So we can view this as y equals x plus 1 and y equals 4. The restriction we have here is x is less than 1 and x is greater than or equal to 1. So let's make a table. What you're working with is less than 1. So let's start at 1. But we know that since it's less than, you're going to have an open circle here. And less than would be 0, -1. That would give us enough. We really just need probably 2 points here. And with our other one, with this one, we know y equals 4. And we know that x has to be greater than or equal to 1. So if we started at 1 and go greater than, and we know this would be a closed circle because it's greater than or equal to. Okay, and now we need to fill in the rest of this one. So we have 1 plus 1, which gives us 2. 0 plus 1, which gives us 1. -1 plus 1, which gives us 0. Okay. So if we let's make our graph in the middle. So on our first one, we have the point 1, 2. So we're going over 1, up 2. And at this point, we need an open circle. Okay, because it's the less than or equal to. And then at 0, 1, we have a closed circle. And at -1, 0, we have a closed circle. So we're working with less than. Okay, so there's our first one. So we can sort of look at our options. That basically does it for us. If you notice, this one is the only one with the open circle and it working to the left. But if we look at the other one, we have 1, up 1, 2, 3, 4. We'd have a closed circle. And then at 2, 4, 3, 4, we're working to the right. Okay. So be careful again with the open circles, closed circles as you work your way through. All right. Let's look at one more. Okay, so this is dealing with taking a word problem and creating an inequality, an absolute inequality for it. So this should be inequality here. Okay, so Greg has some money in his wallet, but you don't know the exact amount. When you ask him, he says that he has $50, give or take 15. Write an absolute value equation to model this situation. Okay, so there's a few different ways to work through these types of problems. I'll use this setup here where it says the absolute value of x minus mean is less than or equal to the tolerance. So if we remember the mean is we're just going to take our values and add them up. X2 plus X1 divided by 2. That's going to give us our mean. The tolerance is very similar. It's going to be X2, but now we're minus X1 divided by 2. Now, what are our X2 and X1s? These are the boundaries on approximately how much money he has. So he's saying he has $50 minus 15 and $50 plus 15. So he could have 35 and he could have 65. up to, so this region. Hmm. So these are x1 and x2 values. So let's plug them in and see what we're working with. So if we find the mean, we get 65 plus 35 divided by 2. So that's 100 divided by 2, or 50. So you might see that's matching something else up in our equation or our given information. And the tolerance then would be 65 minus 35 divided by 2. So that gives us 30 divided by 2, which is 15. So when we set up our equation, we have the absolute value of x minus 50, which is less than or equal to our 15. So that looks like our first one. So this is just one way to look at this type of problem. We're less than or equal to because we're dealing with in between two values there as you're working your way through. All right, I hope that was helpful. Have a good day.